Welcome you all to the Research Spark YouTube channel. This is Dr. V. Chandra from Department of ECE, and this series we are going to talk about the electromagnetic theory and interference. So this is the second lecture of unit first and the last lecture on the unit first. So here we are going to talk about the electrostatics. So basically we are going to discuss about the basics of the Coulomb's law and then the field intensity, electric field intensity, and then the electric field due to the continuous charge distribution, and we'll also see the derivation of the field, electric field due to infinite line charges. So let's start from the Coulomb's law. So what comes in your mind about the charges? So definitely all the bodies definitely have the some attraction or the repulsion because of the mass. So that can be comes under the gravitational force. And like similarly, if you wanted to find out the forces having the some charges, so how can you find? So you can find with the Coulomb's law. So what exactly it tells? So Coulomb's law states that the force F in between the 2 point charges having the charges Q1 and Q2 is always along the line joining them, and then the directly proportional to product of the charges Q1 Q2 and inversely proportional to the square of the distance in between both charges. So mathematically it can be written as F is equal to K Q1 Q2 divided by R square. So this is in the scalar form. So F is a force and K is nothing. This is your constant and the value is approximately 9 into 10 to the power 9 meter per Faraday. And also this force, since force is a vector quantity, so you can write the vector in the vector form like F122, that is equal to Q1 Q2 divided by 4 pi epsilon naught r cube and the r square, and then the unit direction along the AR into 1. And similarly, the field intensity, that is E, can be found F by Q. So electric field intensity E is force per unit charge when placed in the electric field. So this is very similar to the gravitational acceleration, that is G, having the value 9.8 meter per second square. So how can you find? So E can be found like kq by r square, or in the vector form you can write your kq divided by r square and the unit vector along the radial direction, that is ar, where exactly you wanted to find the electric field due to the some charge. So here is the one exercise you should do with the help of the point charges. Suppose point charges is of 1 millicoulomb, then minus 2 millicoulomb are located at the certain point 3 to minus 1 and minus 1 4, and then calculate the electric force on some another charge having the 10 nanocoulomb charge located at 031 and electric field intensity at that point. So how can you find? So since force is a vector quantity, so first find your force at this point 031 due to the Q1 charge having 1 millicoulomb, and then you can find similarly the due to Q2 charge, that is minus 2 millicoulomb, and then you can 8 vector sum. So if you solve, you will get it. So you can check it here, and you can get the results, that is F is equal to minus 6.5 AX and minus 3.8 AY and plus 6.5 AG. So actually this is the vector, this is the electric force due to the Q1 charge, and this is due to the Q2 charge. Okay, so let's move what is the electric field due to the continuous charge distribution. So actually mostly we are talking about the uniformly distributed electric charges. So how can you find out the electric field due to the continuous charge? So it either the charges may be distributed like in the point form or in the line form or in the surface form or in the volumetric form. So if it is point form, so electric field will be the definitely kq by r square, and force is kq q divided by r square likewise. But if your charge is distributed in the line format and the surface format and the volume, then how can you find? So if you know the point charge, the field intensity due to point charge, then you can integrate over the minus L to L in during the entire length, then you will get the electric field intensity due to the entire length. And if you know about the one length L, then you can integrate over the again the entire length from in the length direction, then you will get due to the area. And if you know again the in the area of the particular the field intensity due to area, then you can multiply the integrate over the volume direction, that is height, you will get the field intensity due to the entire volume. So this is exactly the technique to find out the electric field direction due to the some particle or some charges. So suppose for the time being we are going to discuss about the line charge. For line charge having the some charges Q. So how can you find this one? So since we know the field intensity due to the small particle charges, suppose so dq is a small charge, and because of the dq, definitely your electric field intensity, that is E, will be the kq divided by r square. So dq can be written as a rho into dl. Rho is nothing, this is the charge density, and dl is nothing, this is the a small length. So this will be the equal to the q. Now if we wanted to find out the electric field intensity due to this entire length L, which is the located in between the A to B. So like suppose there will be the some particle, the some small particle having the suppose the charge Q. So because of this charge, a small charge Q, what will happen? So because of this small charge, the dE electric field intensity can be induced, and dE will be nothing, this will be your K Q and divided by R square. R will be this one. So how can you find R? So this R will be the this one square plus this row square. So suppose if you can measure this one square plus this one, so in this manner you can find the dE. Once if you will get the dE, means due to this small element dq, then if you will integrate over this length to this length, then you will get the final electric field intensity due to this length L. So this is exactly way to calculate the electric field intensity. Okay, so this is your theta 2 and this is theta. So how can you integrate? So integration, you can have the E of x, that is minus theta 2 to e theta 1 dE cos theta. dE is nothing, the dE is your kq divided by r square. So k is k and q is nothing, this is lambda into dx, if lambda is your charge density and dx is your small element. And then the r is nothing, if this is your x and this is your r, so r will be your x on the root of x square plus r square, and the cos theta. So now just take out your k lambda outside to the integration, and then the just put the value like in order to integrate it, use this formula x is equal to r theta. Just suppose that dx will be r sec square theta d theta. Now just put all these value into this equation and you will get these type of your r sec square theta d theta, then r square 1 plus 10 square theta. Now 1 plus 10 square theta is equal to sec square theta. So finally you will get k lambda by r sin theta minus theta 2 to theta 1 integration. Finally your ex will be the k lambda by r sin theta 1 plus sin theta 2. Similarly, you can find the E of y component just in the similar manner, dE sin theta only, and integrate over to minus theta 2 theta 1, and the output will be k lambda by r cos theta 2 minus cos theta 1. So very simple way. Now finally, if you wanted to find the field, that is field intensity, that is dE, then it will be the square root of ex square plus ey square. So you can get. Now if you wanted to find out the field intensity due to the infinite line charge, so what does it mean? Infinite line charge means simply this point, like observable point, you can bring it to very closer to the length L. In that case, what will happen? Your theta 1 and theta 2, almost both angle will be the 90 degree. So put the both the angle 90 degree in the ex and ey, So sine 90 and sine 90 theta 1 and sine 90 is equal to 1 and 1. So finally Ex will be the 2k lambda by r, and cos 90 is 0, so there is no y component. Similarly, for semi-infinite length, what will happen? Your theta 1 will be 0 and theta 2 is equal to 90 degree. So this is the case while you wanted to find the field intensity at the one end of your length L. So your Ex Ey will be the k lambda by r. So finally, electric field intensity will be the square root of 2 k lambda by r. So in the next session, now we are going to talk about the unit second, where we will talk about the magnetostatics and Maxwell equations. All to listening the session. See you in the next. If you have any problems, please drop your comments. Thank you.